You can be in the video. I just. So we're pretty much done. We just have like 1 week and 1 month and 1 week. But there's Thanksgiving in there, so that's like 5 days off.
When is Thanksgiving? Is it like this week, next week?
Wow. This is today, right? So we have a test on Friday. Next week, Wednesday, we have a field trip to see the music. So we have regular classes Monday, Tuesday, Thursday, Friday. And then the next week, we just have a 2-day week, Monday, Tuesday. And then Wednesday, Thursday, Friday, we have Thanksgiving. So the 25th is the Tuesday before Thanksgiving. So the 27th is Thanksgiving. Now when we come back from Thanksgiving, it's December.
Hey, Christmas.
And it looks like I only have 3 days where I'm teaching you something. 3 days. We're going to come back Monday, Tuesday, Wednesday. And then I have to figure out what we're going to do for these 2 days. Like, we're going to start the next section. That won't be on the final. I gotta figure something out. Then we'll review and have a final. That's on Monday and Tuesday as well. Probably could do it here on this Friday. And I have 1, 2, 3, 4, 5 days, which is a lot of days reviewing for the final. Like going over everything we learned all year. And then we'll final. So I'm going to answer questions that you might have on 4, 7, 1 through 13 all. Bless you. I don't know if I ever opened. Gosh, I feel like I opened. Bless you. That's 4, 8. Or 7, 1 through 13 all. Any questions with them? Oh, this was just multiple choice. So if you start here, the best way to look at it is track the center of it. This one, the center goes straight, exactly to the right, 2. So that's obviously B. This one, it goes left 2, up 2, which is obviously C. This one goes right 2, up 2, obviously D. And this goes down 2. That's A. That's fun. And, whoa. What did you have to do? Graph each function. So I think you're graphing the parent function and the transformed function. Any questions with these? No? We're good. Yeah, let's look at this next section. Analyzing graphs of polynomial functions. So, you've seen plenty of graphs of stuff, right? Sometimes it goes like this, and then it goes down forever. Or sometimes it makes like a W, and it goes up forever. If it looks like this, it has some important spots. Local maximum. This is a local maximum right here. This spot. It's like a little hilltop. You know, like us. right? A maximum is a little hilltop, and a minimum, a local minimum, poor guy. Local minimum is like a little valley bottom. So these have points, and coordinates are the points. And that's what you're gonna find. Local max, local min, even function, odd function, end behavior, increasing, decreasing. Okay. So let's just make up some points just for the sake of explaining. Say this is the point -1, -3. That's -1. And this is the point 5, 7. Okay? So you're going to have to list some things, some characteristics about the function. Okay? So a maximum. I guess we'll make it a point, is a point. In calculus, a maximum is just a y value. So you would say there's a maximum at x equals 5, and the maximum is 7. So a maximum of 7 at x equals 5. But we're not going to do that. Maximum is the point 5, 7. Okay. You know how let's see if I can fix something. Okay. Calligraphy pen, where's that? Yeah. This is what I usually use. Boy, that's pretty thick. I'll have to change it. Minimum is a point where it hits the valley bottom. In this case, it's the point -1, 3. -1, -3. Okay? Now you have to describe where the function increases and decreases. Have we done that this year yet? Okay, well that's good. So, the way you do that, this is 5, and this is -1 on the x-axis. So the function decreases, increases, then decreases. It increases in between -1 and 5. So that's what you say. -1 less than x less than 5. It decreases here less than -1 and also decreases here greater than 5. You're going to have to be able to describe that for the quiz just before Thanksgiving. Also, there's a spot on your calculator where you can find the x-intercepts. You can list points or you can just list numbers. Got it. Okay. Y-intercept might change. Another thing to notice. All right? I guess that's all I'm going to talk about today. How many turning points? So a turning point is like this. So this is one turning point, and that's another turning point. Do you know what the degree of this graph is? What's the degree of the polynomial, do you think? Yeah. What is it? 3. A polynomial with a degree of 3 can have 2 turning points. Just like if I graphed a line, it doesn't have any turning points. It just keeps going down in the same, direction. But the degree of a line is 1. The degree of this, probably 3, right? So a function's degree is typically 1 more than the number of turning points it has. Not always true. That's what this, how many turning points can the graph of a polynomial function have? So this is an interesting concept summary. A 0 is where a function crosses the x-axis. A factor, you can get from a 0, it's typically a binomial, but it can be more, right? It's typically x minus the 0. A solution is k if you have an equation, a function equals a number, or equals 0. And you can find the solution, you can graph it and find the x-coordinates or the x-intercepts, or you can factor it and find the solutions that way. But that's what a solution is. And an x-intercept is where a function crosses the x-axis. And the coordinates of the function are k times 0. So they're all 4 of those things related. Zeros, factors, solutions, and x-intercepts. Also called roots, by the way. Graph this function. You're going to have to get a little bit more correct about this. Like, what do you know about this, the graph of this? Do you know what the leading term is? It is this times this to this power times this to this power. So what is the leading term? 1/6 x to the third. 1/6 x to the third. Okay? So we know some things about it. We know that it goes it goes up on the right side. What does it do on the left side? It goes down on the left side, right? How about the y-intercept? Holy moly. Why is that? It's going to ruin my day. Still bad. So if I pick this up, why would it change? I updated it today. The x-intercept. It's the last term in each one of these factors. So it's this number, same number, 1/6, times this number to this power, 3, times this number, -2, to this power, squared. That is the y-intercept. Because if you FOIL all this out, you get a big long polynomial. The first term will be x squared times x times 1/6. And the last term will be -2 squared times 3 times 1/6. Because you distribute that 1/6 all the way through that whole polynomial. So it's part of the first term, part of the last term. So this is 4 times 3 is 12 times 1/6 is 2. So this is going to cross the y-axis 2. That is a 1. Across the y-axis 2. So when you graph it now, we're going to be concerned about the y-intercept as well. So where does it touch the y-axis? Yes. x?
2 and
Positive 2 and
-3.
-3. -3 and positive 2. Some people put x's when it does not go through there. And just put a dot when it does go through there. And I know it doesn't go through at positive 2 because there's power of 2 on it. That means there will not be a sign change. That means the y value will not go through the x-axis. Okay, so I think we know enough to graph it right now. What's the right side do based on this leading term? Goes up. Okay? So we know that. Right side goes up. What's the left side do based on this leading term? And I know it goes through this and it goes down. So I think I know enough to graph it. It has to connect all of this. These dots and that dot. So maybe it does that. And that's, we're not going to be concerned about how high it goes or how low it goes yet. That's what we got. Graph the function. I think we should look at what we see. You guys want to graph the first one? I'm going to look and see if we're looking for the maximums and minimums on the first example. You might have to. They made a T-table and put numbers in it. It's good enough. Is a field trip back? Did you guys go on it? Just seniors? You're gonna answer this question. What number are you giving me? What number are you gonna give me? I already did 1, 2, 3, 4, 5, 6. We're at even twice. Oh, I see. Okay, Isaac, what do? We're at this.
Find the leading
All right, what is it?
1/2 times x squared.
So it's 1 and x to the third. So we know the right side goes up, the left side goes down. Now what?
Find the y-intercept.
What is it?
1/2 times 1 times -4 squared.
And that's
8.
8. So 1, 2, 3, 4, 5, 6, 7. There's the y-intercept. Okay, good. Now what? Well, where is it across the x-axis for this factor?
-1.
Negative 1. And what does it do here?
It just touches that.
Watch this mess. It just touches it. I erased everything. Oh, that's why, because that was the dot. -1, and touches it at 4. So, we know the right side goes up. No, we know it does not go through there, so it would be like that. It has to go through this point and that point. Something like that. Okay, everybody good? Mateo, no, you're not good. It's terrible news. Maybe you should help me with the next one. That'll make you good. Do you know where it crosses the x-axis? What numbers? I can't hear those wrong numbers. What numbers? Okay, you're telling me -2, yes. +1, yes. +3, yes. Does it ever bounce off the x-axis, or does it go through every time? Okay. Well, you can tell if it doesn't go through or it does go through based on the power on the factor. If the power is 2, then it doesn't go through. If the power is 1, it goes through. Through, and through. All 3. Do you know what the leading term is? What? We have to do like this up here. This number, 1/4, times this to this power, times this to this power, times this to this power. That is 1/4 x to the 3rd. That means the right side goes up, the left side goes down. Do you know what the y-intercept is? Yes. 1/4 times 2 times -1 times -3. That number. What is it?
1/4.
erase anymore. My whole thing. Gone.
So it's gonna be 6/4.
6/4. 6/4. 6/4. 3/2. 1.5. 1.5. Okay, that'll be fine. Right side goes up, so this one goes through though, so it goes like that. Left side goes down, through. And then just connect all those points with a smooth curve. Probably do something like this. We're good. Any questions? Stuff you already knew, kind of. All right. If a polynomial function and a and b are two real numbers such that f of a is less than 0, f of b is greater than 0, then it has at least one real 0 between a and b. That's weird. I need water. Oh, I do not have water.
You want me to look it up for you?
No. I don't want you to miss this. Okay, so find all the real zeros. How do we do that? Graph it, find the easy one, do synthetic division. Once you guys do that, I'm gonna get water. I hope I get to see the 30,000 bottles saved. And then Spencer, that would be very exciting. Any luck? You find X value? Ooh, that looks like -2. For sure. You got that, 2? -2? Ooh, -3. And then we can find the last two by using the quadratic formula. Find all real zeros. So x equals -2. B squared minus 4ac. -7, 6, -3. So 49 plus 72. $121. Really? That's nice. So the last two are x is equal to -b plus or minus the square root of 121, which is 11. All over 12. 18/12, which is 3 halves. And 7 minus 11, -4/12, which is -1/3. So, yeah. 3 halves. Those are zeros. Because you've gotten those?
I'm sure.
No. It does now though. 121, that was a miracle. Miracle. All right, what about this? One of these, there is not a nice one. It turns out to be cruel. Here, 18x to the third. Plus 21x. Oh, this is it. That's what I got. There's like one in between -1 and -2. There's one in between -1 and 0. There's one in between 0 and 1. So what do you want to try? Does it look like that's like -1.5? I'm going to check to see if that is it. Oh, -1.5. 0. I've already checked it. So we're going to use 3 halves. X minus 3 halves in the box. So multiplying by 1.5 is a little tricky because it's like tipping. Right? If you have a $40 bill and you have to tip somebody and you want to tip 15%, isn't quite to 20%, which I think is still enough. If you want to tip 15%, you take 10%, which is 4, and then half of that, which is 2 more, and that makes $6, is 15% of $40. So we're going to do 1.5. So the 18 drops down. 1.5 18s. It feels like it's going to get really big really fast. Was it -1.5 or +1.5? Oh, thank you. 3 halves of 18. Half of 18 is 6 times. Half of 18 is 9 times 3 is 27. It's -27. Add these together. You get -6. -1.5 times -6 is all of 6 plus half of 6. 9. Add them together, you get -4. 1.5 of -4 is all of it plus half of it. -6. Negative times a negative is positive. -6. -0. So one of the zeros is -3 halves. Now we can use any means necessary to factor this last thing. It does not look nice in the slightest bit. F of x, by the way, is x plus 3 halves times 2 times 9x squared minus 3x minus 2. Ideally, that factors. best thing ever.
All right, I think you guys know enough to do the assignment that I have assigned. Have a great